Okay, the topic for today is quadratic functions. The very first thing that we are going to talk about today is the graph of a quadratic function. The graph of a quadratic function is a parabola, and that is the shape that you see right here in this box. And the parent function of a parabola is f of x equals x squared. So I know that one of the things you're going to have to do in your video is relate things to the parent function. And that is f of x equals x squared. Now, if you go back up here to the top of the notes, the parabola is what this shape is called. It is the graph of a quadratic function, and a quadratic function, you need to know, is written in this form. F of x equals ax squared plus bx plus c. In the parent function, which is just x squared, the a is 1, and the b and the c are 0, so you just have the x squared. But all quadratic functions can be written in this form, where a, b, and c are just numbers. All right? And we're going to talk about all the different forms, because there are, just like with lines, different forms that you can write quadratic equations in, and you get different information depending on what form it's written in. All right, so let's go up here, and I want to point out right here, this is something called standard form. The vertex form of a quadratic equation is this. F of x equals a times x minus h quantity squared plus k. It'll take us a little bit of time yet before we do this, but one of the things that we are going to learn how to do is go back and forth between standard form and vertex form. It's easy to go from vertex to standard, and it is much more difficult to go from standard to vertex. But we're going to learn how to do both. All right? Okay. Some of the features of the graph. The axis of symmetry, just like we had for the absolute value functions, we have an axis of symmetry. All right? So in your graph, and you can barely see it here, but it's this dashed line right here. This is your axis of symmetry. And in this particular function, that line is the equation x equals 0. All right? Remember, the axis of symmetry means that on that line, both sides of the graph are mirror images of each other. So notice, the left side of this graph is a mirror image of the right-hand side of the graph. Now, the vertex of the parabola is HK. And remember HK? HK was the vertex of the absolute value function. Guess what? HK is the vertex of a parabola. And do you remember with the axis of symmetry? The equation for the axis of symmetry with an absolute value function was x equals h. Same thing with a parabola. And I think we're now beginning to understand that it's not just h, it's the equation x equals h. Okay, because I know that came up as an issue on that Chapter 2 test. So, the vertex of the parabola is this point right here. The vertex. All right, we need to get the shape of a parabola down, essentially. The shape of a parabola, because here's the thing, I don't want you to have to plot points every time you draw one of these. I want you to be able to use transformations, because I think that by now you have found that using those transformations is actually faster and easier than trying to plot points every single time you want to graph something. And that's what we're going to do, is use transformations. But before we can start transforming, you've got to know what the basic structure of the parent function looks like. So what I'm going to do is a table of values for the parent function, just for the parent function, and all other ones come from that basic structure. So I have some x values, and then I'm going to have y equals x squared, and this is our parent function. So I'm going to do -2, -1, 0, 1, and 2, and this is going to give us the basic shape of the parent function parabola y equals x squared. So x squared here is 4, x squared here is 1, 0, 1, and 4. So what you need to realize is the parent function has its vertex at 0, 0. It has a point at 1, 1 and at -1, 1. And if you notice, that's 1 up, 1 over, and 1 up, 1 over the other direction. Okay? Now, at 2 and -2, you're going to go up 4. So here's the deal. To go from this point to this point, you're going up 3 and over 1. From here, you're going up 3 and over 1 the next way. This is how the parent function graphs. And if you know the structure of the parent function, it'll be a little bit easier to do some of the others. So the very first thing that we're going to do is we're going to graph the function in the form f of x equals a x squared. So here's an example. And what do you think? Just let's think a minute. Based on what you know about a in transformations of absolute value and linear functions, what do you think a has to do with for quadratic functions?
Slope.
Well, it's like slope, but a parabola doesn't have a slope. What do we call that? What was it called?
Rise of the rod.
No, not slope.
Vertical.
Translation. The compression.
Compression, and what's the other direction? Stretch. This is compression and stretch. So if you look at just the A greater than 1 is stretch, and if you have an A between 0 and 1, that is going to be a compression. So guess what? This is going to be compressed. It's going to be compressed vertically. So, whoops, I got to stand in front of here so we can all see me. Compressed vertically. So this ends up getting squashed down and it becomes wider. All right. Glad I'm wearing my Laker wear in the video today. Okay, it's all good. So here's what we know. This function is going to have the same basic shape. We don't have any vertical or horizontal translations. This is going to still have its vertex at 0, 0. But at this point, we haven't really learned a lot about the translations. So I'm going to do just a little bit of making a table. And you're going to notice that I'm going to do something specific here. And that is, I am not going to do both negative and positive points. And the reason why is I don't have any vertical or horizontal translations, so I know my vertex is at 0, 0. But if I can find the points on one side, the points on the other side are mirror images because I'm going to have an axis of symmetry like this. So axis of symmetry, and that is the line x equals 0. All right, I have a fraction, so if I'm doing points, it's nice to put in a 2 instead of a 1 because 2 divides by my denominator 2. So 1/2 times 2 squared, would you agree, equals 2? Okay? So I have the point 2, 2. And over here, I have the point -2, 2, because I have a mirror image point. All right, so when you look at these, like here, mirror image. And if I put in a 4, I have 1/2 times 4 squared, which is 16. Half of that is 8. So it's going to be way off of my particular chart. What if I did put a 1 in? What would I get as my y value? A half, because I would have 1 squared is 1 times 1/2 is a half. So it would be really right here, and there would be my mirror image. So what I want you to see is this. Do you remember how in my parent function it was up 1 over 1, up 1 over the other direction 1? With my a at 1/2, it's up a half over 1, up a half over the other direction 1. And do you see how here at this point it was up 4 over 2? All right, it's going to be half that, up 2 over 2. So here is my lovely parabola. All right. And let's turn the page.